my name is Shaunak. I just wrote you mails from India. It is a real honor from India, from me and from my entire family to you, sir.
Okay, namaskar. Tell me.
And I was so very happy. I was, I was extremely honored when I found a little bit of your interview with Mr. Ravish in a news channel, and also
he was being very mischievous.
Oh, really? Because it's turned out to be so. I was just watching it in YouTube. It was not a proper, a proper interview given, really.
Yeah, he was taking more a dig on the government than, but anyways, I ignored that.
Yeah, I understand. So, and there was one small 1 minute 40-second interview of yours, possibly in Cambridge, which was being uploaded by somebody from Kurnool. So I actually was faintly hearing that the sound was too low, and then I came to know that you have been working with Dr. Hawking and on the de-Sitter space. So what was, sir, your initial interaction, the first time when you met? What was, if you can just explain in a few words?
Well, I walked into the department here in Cambridge. I had written an article, and that is what was noticed by him, and he had me over.
Okay.
So he accepted me as a student. So I was a student of Stephen Hawking, and initially also of Gary Gibbons, because
Gary Gibbons, right?
Initially, I had to get used to the way Stephen was speaking.
Okay.
And then
this was which year, sir?
My first 78.
78. Okay.
So as soon as I entered his room, the secretary just stood between me and him and asked me whether I knew. So I thought maybe because he's not well, that's why she's trying to take precautions.
Okay.
I just told her that, look, I know about his problems.
Right.
She moved herself, and then what I saw shocked me, because there's nothing I could have prepared myself for this. I just saw kind of a heap of clothes on which there was a head lying.
Right.
And I was shocked. I was then his then wife Jane walked in, and I spoke to her.
Okay.
And she took us. I just walked with them home.
Okay.
Stephen and Jane and I walked to the place, and Jane treated me to tea.
During this time, Dr. Hawking was unable to speak.
Well, he was able to speak at that time, but his voice had a lisp, and it would be slurred. But after some time, one understood. It took me about 2 months to kind of understand him. Okay.
So that was your first interaction. So, sir, when you, because I went through the part that there was a paper on charged particles from black hole. You have written, I found one paper of yours. So, sir, when you went to Dr. Hawking, I just wanted to know in layman's word, what was the remarkable work of yours that actually made Stephen Hawking feel that the collaboration can be joined? Like, what was that seminal, remarkable work?
There was this article that I had written in 1974, which was communicated in 1976.
Okay.
Because my teacher here could not quite understand what I had done. So I sent it off to the Physical Review, and the editor Weisskopf wrote a letter to me that, look, just about a week before they had my paper had been received by them, they had accepted an article by Stephen Hawking and Gary Gibbons with the same result.
Okay.
And so they sent my article to Stephen Hawking for refereeing.
Okay.
Stephen Hawking. That article, I would say, is what made him notice me.
Okay. Sir, if I ask you in a layman's word, what would be the basic nutshell? What would be the gist of that article? Is it too technical to explain?
No, not at all. It just showed that the way we define a vacuum in quantum field theory depends upon on some what are called basis functions. Depends upon the topology, large-scale topology of the box in which you are, which should be large in comparison to the size of the apparatus or the system that you're working on. But, so normally the shape of the box doesn't matter. However, if the box is, let's say, expanding with the universe. So I use the time boundary time variation of that basis function. And if that boundary is expanding into the horizon of the universe, called the density horizon. In that case, no particle state
I got it.
Defined in such a frame corresponds to thermal flux of particles in the normal state. So that I determined the temperature. I wrote this in 1974. I was not aware. I applied it to the universe, but Stephen Hawking had applied it to the black hole. And it got the temperature of the black hole.
Which is called
the same thing for the black hole. Then I would have. It's really.
I think
I didn't know that thing had been done for the black hole.
Yes, if you would have applied to the black hole, then possibly the thermodynamics of black hole, or which was later Dr. Hawking called as Hawking radiation, would have been come much earlier.
Yes. So there is a varying boundary condition.
Varying boundary thing, right.
Boundary conditions and the existence of what is called the horizon. Is what was. I applied it to the distant horizon of the universe, and he applied it to the black hole horizon.
Right. Sir, the last time when you met Dr. Hawking, that was in 2007, I believe.
No, 2017.
2017. It was in Cambridge, right? So I found that. I found that you have written his conditions were frail. So can you just give what was actually what was the condition? He was not at all well. How is it?
No, he was very unwell, and he, in fact, there's something I'm working on. He was 75 at that time.
75 years.
75th birthday.
75th birthday. Right.
So he just, I met him briefly. We had gone to his house for his birthday party. There was also this conference in his honor. So when I went there, he just asked me how my book was progressing, and he told me to hurry.
So he knew that it was coming to an end.
Yeah, he just wanted me to write whatever I had done. And to summarize it. But I'm still working on it. I've not finished it yet.
So, sir, with Dr. Hawking in Cambridge, if I take a tenure, how long you have been working? 4, 5, 10 years? How long?
Look, I was his student, and Gary Gibbons' student for 4 years.
4 years.
1978 to 82. But then I kept coming back. My association, almost 3 months every year, I would come back to Cambridge. And then on 5 occasions for longer periods, I got an EEC fellowship. I was here for 2 years at that time in 1992. Then I got this Royal Society fellowship for 6 months duration each. Then there were 2 sabbaticals, and then about 3 months every year. So Cambridge was like my second home.
Right. Sir, I just have one question more. The last theory, the last, I would say, proposal or whatever of Stephen Hawking was the no boundary theorem. Was that the last work he did?
No, you see, the no boundary proposal was much before. I mean, it was in the mid-80s.
Late 80s.
So it's just a mathematical trick. People don't really believe in this. Now, and then we have to invent basic working rules which are very artificial. I'm aware of this, but for lack of anything better, he was just working on it. However, Stephen would be most remembered for a debate that his work on black holes created, because
Leonard Susskind.
the Hawkings is it goes by the name of Hawking paradox.
Hawking information paradox. I think it was with Dr. Leonard Susskind also.
Yes.
Okay, I have read that.
Pointed out that this is a crazy idea,
Right.
but nobody has been able to resolve it till date. But Stephen was so severely criticized because in string theory,
Okay.
people discovered some solutions. There are two dimensional constructs which have a similar behavior, but they have nothing to do with the actual four-dimensional black holes that you have in general relativity. But those are some different constructs, and for which you can put the degeneracy. You can you can actually see what the entropy is relative to.
Right.
And there is no loss of unitarity there.
Right.
So people conjectured that Stephen Hawking, the realistic black hole, the result also suffers from that same issue.
Okay.
But nobody was able to. But Stephen Hawking nobody was able to prove it for four-dimensional space-time yet.
Right.
However, Stephen was so under such severe criticism that in 2005,
right,
in a conference in Dublin, I attended that as well.
Oh, you attended that? Okay, right.
Yeah. So he just came out with a proof. That he was wrong.
Like Dr. Hawking came out himself with a proof that he was wrong.
Yes.
That was great.
But then just about as soon as he saw the paper, then we all, 4 or 5 of us sat with him and we showed that the proof was fraud. So the problem is still open. And people like, what's his name, Poincare and others. Poincare was also in the department he was doing. He's a particle physicist.
Right.
They believed his original result, and they said that he just unnecessarily gave up too early. And they believe in his interpretation.
So
it's basically it's basically the paradox basically has to do with what is classicality, what is a classical object. I mean, how do you go from a quantum result to a classical result?
Classical, right.
What is a classical black hole?
Right, absolutely.
So in actual physics, there is no such thing as a classical physics. I mean, it's a quantum field theory is the right theory. But then how do you, the people still, they keep on debating on the interpretation of what is a classical object. What is quantum decoherence? What is one? So there are still people, there is no consensus on this issue. So still, the resolution of the Hawking paradox would lie in that once you have once you're settled as to what is classical physics, then you can see what is semi-classical physics.
Sir, I always wonder when I see the videos of Dr. Hawking, like speaking through moving his cheek muscles, etc. How did you find his wife, like Dr. Jane Hawking? Like, I just want to understand, like, you have talked to Jane Hawking, you have talked to his wife.
She's a wonderful person.
She's a wonderful person.
I still am in touch with him. Yeah.
Oh, you are still in touch with him. Okay.
With her.
Sir, can you give me any idea, like the way Dr. Hawking eats or drinks, like how does he do that? Like, is there any mechanism that you have seen the way he eats or drinks? How does it happen?
No, he doesn't, but somebody has to feed him. And when you feed him, his head is, you have to hold his head up and then he just drinks.
But he can swallow things.
Because of the weakness in the muscles.
Muscles, right.
Part of it comes out, but then he just drinks a little.
Right.
Something goes in. That's the way.
And this Hawking radiation, which is basically known as, sir, to be very honest with you, because I'm frankly speaking, like these are calculations and estimations, like I think like quite far off. Like, do you think that experimentally can it be proved that black holes do emit particles or any calculations, whatever? Like, is it just an estimation, or technology will advance in near future to actually visualize and see that yes, Hawking radiation exists?
Look, it's not okay, and to have an actual black hole emit Hawking radiation is going to be impossible.
Impossible. Okay.
It's very, very weak. However, if you have a radiation bath,
okay,
at a very high temperature,
okay,
then you can have there's a finite amplitude, the probability of a virtual black hole and an anti-black hole.
Okay.
Pair,
okay.
Created out of vacuum and gets annihilated. So it's a closed loop.
Okay.
But when in that virtual process,
okay,
when the black hole exists,
right,
in that case it'll have a very low mass.
Okay.
The mass would depend upon the temperature of the bath.
Okay.
So,
fine.
Then there is at that time,
right,
you can have a process in which an electron is absorbed by, or let's say a proton is absorbed by the black hole, and spontaneously an electron is, a positron is emitted.
Right.
So
okay,
charge is preserved, but the barrier number would be violated.
Right.
So, and such a process, this is not, so it'll just be an positron just converting into a proton.
Right.
So, but the probability of this would be damped by exponential of minus the action of the black hole, which is very large.
Right.
So the probability is going to be very small.
Right.
But so this kind of a process could be an indicator of
right.
this process.
Right. Sir, I know you must have heard about Poincare conjecture, which recently has been proved by Grigory Perelman, the Russian mathematician.
Yeah.
So, sir, the thing is that, like, for me, I don't know how to ask this question. I read about Perelman, and I found that 3 to 4 times even this $1 million prize, the Fields Medal, he has declined. Now, right. Now, I was actually, my basic background goes much into Vedas and Gita and the religious scriptures of Hindu, because I am associated with Ramakrishna Mission Institute of Culture. Now, I just have this question to you. I know it is weird, but just consider this to be my craziness. Like, I read a lot of interviews of Perelman, okay, and he's a crazy person. We all know everything. Now, he told that I don't need that money. Why? Because proof is the final thing. I have proved Poincare conjecture through Ricci flow. That is fine. So what to do with money? Do you want to keep me like an animal in a zoo? So I don't need that money. I have proved it, and I'm a servant of science. That is all. Like, do you think this could be like a real saint or a monk, or a different kind of a philosophy that this person has, who denies so much amount of money, not little bit, but $1 million, and proves the most difficult millennium problem? So what would your opinion regarding this conjecture would be? Like,
No, I have no opinion. It's very interesting.
Yes, very interesting.
He could have taken the money and given it to me.
Yes, my wife was discussing that he could have taken that man money and give it to a lot of poor people, like in a charity or something. So why I ask you, sir, this question, that, say, for example, theoretical physics, I have seen that you have done researches in Tata Institute of Fundamental Research, TIFR, Poincare conjecture being proved, universe where it is starting and beginning. So do you see an end in science? Like, like if I take the four forces of nature, electromagnetism, gravitation, strong and weak force, do they merge at one point and we are all striving, like the Large Hadron Collider, LHC or whatever, can they create that temperature, or can we, through either mathematics or through meditation, are we striving towards one energy point where all these forces are being merged? And might we call that as God or a superpower? Like, do you, because you have been an extremely, in a different kind of a world with high-end physics, mathematics, and IQ level up to the level that we cannot think. So, what is your perception, sir? Do we see an end in there, or?
No. Look, there is one has. Have you heard about? Have you read the work of Gödel?
Gödel, yes. Kurt Gödel, yeah. I have read a lot about Gödel, incompleteness theorem, everything. Yes, sir.
Yeah. So the point is that we are here. The game in physics is actually very. It's very kind of mundane. You just look for a mathematical structure, and you are just trying to fit in observations.
Right.
So it's kind of this grand empirical. It is basically empirical work, but you just hide it in some grandeur and give it some kind of as if it has something fundamental to it.
Right.
But it's basically data fitting, which is kind of dressed and packaged in some very grand manner. But in data fitting, you are basically using some mathematical structures.
Okay.
And when you so even in mathematical structures, there is still no consensus, and Gödel showed that there cannot be a consensus.
Right. Absolutely.
Even the nature of proof.
Right.
So what should be accepted as proof? So when you talk of fundamental theory, which proves everything, you are just bordering in that realm.
Okay.
So it's basically an exercise in futility.
Okay.
So the idea or just the goal of physics is really to just you have lots of some mathematical paradigms or mathematical structures, and which have this basic. Each of those structures suffer from the Gödelian knot. However, you just forget about that aspect of the structures and see whether there is an interesting structure that you can just borrow and plagiarize and fit some data in physics.
Okay.
That's it.
Okay.
So this is it. There's nothing more and nothing less.
Nothing more and nothing less. So philosophically, sir, what you are telling is that we are just trying to fit something, wearing a better dress like coat and pant and tie and shirts and things like that. So it is nothing.
You look at coincidence. For example, I saw some article in which I was laughing. I was sitting with Michael Atiyah, the great mathematician from Oxford, he's also in Cambridge. He was a master of things.
Yes, I have heard about Mabi. He's a legendary figure.
So he's no more now. But Michael Atiyah, I was sitting with him, and I just, while we were relaxing in a reading room, I just read an article in Nature, and somebody had published a stupid article which said, a solitone model for memory. Now, solitones are some mathematical structures which have a definite meaning as far as the mathematician is concerned. But there is one thing, there is a play of words. The dissipation also has a mathematical connotation. But dissipation in normal language has some other meaning. So, but this person not bothering about what dissipation meant, just because solitones do not dissipate and memory doesn't dissipate, so he just had a
it's like
he had a solitone model for memory.
Right.
Now, this is crazy. It was so stupid. So when I laughed, Atiyah asked me why I was laughing. I said, this is just borrowing words and so on. It doesn't make any sense.
Right.
Then he smiled at me and said, I thought all physics was that.
That is what Feynman also told that, right? Absolutely.
Yeah. So it's just, you're just borrowing some structure with no a priori reason.
Right.
Just fitting data using that.
Right.
And then when you realize that this is just grand, even the classical physics, it's just Newton, for example, formulated this initial value problem.
Right.
That, he just said that, all right, if we have a second order of time derivative operator, and if I relate it to a force field, and then I can, because the second order in differential calculus, you can then define trajectories, which can be determined once you have the initial data.
Right.
So this became an established practice. People forgot that this is just, what is the reason? Why should people use a force field in 3 dimensions? And why should, so these 3 dimensions and all that, these have specific meaning in topology.
Right.
Now, all that was given a miss, and people just started using lots of rules.
Right.
And people became masters of, it's like, in India, आना पाई and पता नहीं तोला माशा चलता था पहले.
अभी नहीं चलता है जी बिल्कुल.
So now at that time, during my father's time, people became experts in multiplication of 1/12th, multiplication of 1/20th or 1/27th.
Right.
So all those people were considered brilliant. Somebody can do all those sums in a jiffy.
Right.
So big deal, what was also fundamental about 1/12th, these are just some rules. Some rules are invented and people become experts, and you give them awards.
Absolutely.
It's such a stupid exercise.
Absolutely.
So the same thing, a more grand, so that you just look at a structure which has a lot of potential for complicated exercises, and anybody who can do that becomes an expert.
Absolutely. Sir, I think that what you have told, I also have a similar opinion. Pardon me if I am wrong, the popular science books, like which are written by, say, Michio Kaku, and then, say, for example, this person, Brian Greene, etc. Although one good part I feel is that the young people are taking interest in what is string theory and general relativity and quantum mechanics and QFTs, all those things. But don't you think, sir, that without the usage of a single equation in a 300 or 250 pages book, it is actually misguiding the young people, and they are making certain romantic and ultra-romantic, I would say, some kind of a vision that, stephenhawking and black holes would be, but black holes, etc., are all equations. If the equation proves to be infinity, it becomes like that. If the equation becomes 0, it becomes like that. So don't you think that at one way, these popular science books are actually damaging the real part of science?
Yeah, I mean, you have to take them with a pinch of salt.
Right. Right. So I was going to the paper of Dr. Hawking, the PhD.
By the way, in the brief history of time, there were I was a student here. I was in Cambridge.
Okay.
Did you read my story? Which in TIFA, in 2018, I gave a colloquium in memory of Stephen Hawking.
Okay, 2018. Okay.
It was called Remembering Stephen.
No, sir, I was actually searching for that article. But if you be kind enough, once we end the conversation, if you can just pass the writing part in my email, that would be great.
I don't know. It's in my computer in the university, but I can't remotely access it. But it's in podcast. You can download it from the TIFA website.
Okay, in podcast.
Okay, so there I described how when I was a student, I had finished my PhD, but I was still hanging around.
Okay.
At that time, the editor of the Times and Carl Sagan, they were visiting the department, and they gave...
Carl Sagan was also great. Okay.
So they gave him the idea of writing a book on what happened in 1982, the famous conference in Cambridge in which Alan Guth and others came.
Right.
So and a popular book.
Okay.
He came to us. It was there was Brian Wick, and Bruce Allen, and requested us that if we could help him, collect material and write the book, because he couldn't write it on his own quickly enough.
Right.
So we agreed, and we said that all right, but we agreed only on one condition, that the underbelly of Cambridge should be exposed.
Okay.
And he said, what? So the underbelly of Cambridge is things like facts like Newton actually didn't discover calculus. Newton plagiarized calculus.
So who discovered Leibniz?
Leibniz did it.
Yes.
And Newton and Leibniz had a priority fight. Leibniz didn't know, and that Newton, Leibniz didn't know that Newton was the president of the Royal Society, and Leibniz just agreed to send it for arbitration to the Royal Society.
Okay.
And Newton, as a president, appointed 3 of his closest friends as arbitrators, and he wrote down their award in his own favor.
Okay.
So we wanted all these stories to be put in. So these are given in the appendix. Initially Stephen refused, but then we said no. So then Carl Sagan said, "Oh my God, this would be dynamite."
Okay.
So, and again, Newton did not discover gravitation. It was Robert Hooke.
Right.
These things.
Yes. Yeah, actually, these things are, yes, you are very right, sir, telling this. Sir, did you meet Carl Sagan in person? Like, how was he? I am thrilled to hear his stories, like in YouTube. How did you find him, Carl Sagan?
Not really. I was not impressed by Carl Sagan. I was more impressed by people like Richard Dawkins, and who I've met again in person.
Richard Dawkins,
Carl Sagan is a great photographer, and he is a filmmaker.
Okay, yes.
Carl Sagan series have no coherence. He would just be talking about a galaxy, and then suddenly talk about a bird, then suddenly talk about a fish. But there's no coherence. I mean, where are we going?
I got your point, sir. Sir, have you met Dr. Leonard Susskind?
Yes, of course.
Sir, can you just tell a few words about him? I am fascinated to hear his generativity lectures in Stanford and YouTube. But if you just share a few words, it would be great, sir.
No, he's a very good teacher and a very angry man.
Oh, really?
Yeah. Okay. He on Stephen Hawking's 60th birthday, he went hammer and tongs. This was in Cambridge.
Okay.
He went hammer and tongs after Stephen Hawking.
Oh. Okay, is it so? It seems that he is a very nice, calm and composed person, speaking slowly and explaining things. So, like I watch the lectures. Even my daughter, she's in front of me. She is just 9 years old, and she even knows that person with long beard is Dr. Leonard Susskind. So we actually, yes, and she also knows who is Stephen Hawking. Sir, one thing, have you met Dr. Roger Penrose also?
Yes.
So how is he? Can you just share a few words about that?
Let me just tell you something very honestly.
Yeah.
Penrose is solid.
Okay.
He's he's a dreamer. Penrose is the person who has had much more significant contribution.
Okay.
In philosophy of physics or whatever, in
singularity,
and even in the singularity theorem,
right?
Than Hawking.
Okay.
Of course, and Penrose is a delight to listen to.
Oh, really? Yes. How? I think he must be now around 70, 80, 81 years old, I think.
Yeah, he is 80 plus, definitely. He's
10
years.
Oh.
10 years he is into Stephen.
Yes, he is in Cambridge only. He is in Cambridge?
No, he's Oxford.
Oh, sorry. He is in Oxford University. Right. Yes, I have heard Penrose. I have read his book called The Emperor's New Mind, The Shadows of the Mind. So, like, I often hear to YouTube lectures of Roger Penrose, etc. So, sir, I won't take much of your time. I'm so sorry, but thank you for giving today's time.
You could just send me questions that you would like to ask, then I could
Sure.
Okay.
I will do. Thank you very much, sir. Thank you very much for your time. Excellent speaking to you. and good day, sir. Bye. Bye. My name is